there are 4 conditions that should be present. Now let me just look on this scenario. This is a binomial distribution scenario. Let's consider tossing a coin 40 times and recording the number of heads obtained. Okay, this is binomial. Now there are 4 conditions that will help me to make the conclusion that it's binomial. The first condition is that there must be a finite number of trials or observations, right? And here for this experiment, I'm tossing the coin 40 times. So that's a finite number of trials, okay, or observations. So n is equal to 40. The other condition is that each trial has only 2 possible outcomes, right? One outcome we're going to consider success and the other outcome we're going to consider failure. So when I toss this coin, I'm going to have either head or tail. 2 possible outcomes. Getting a head would be considered a success because I'm recording the number of heads, so that's success. So getting a tail would be considered a failure, or not getting a head would be considered a failure. The other condition is that the probability of success must be constant from trial to trial. Now remember, success is the probability of getting a head. Success is getting head. Now the probability of getting a head is 1/2, and that is constant each time you toss the coin. That doesn't change. So the probability of success is constant from trial to trial in this scenario that we're looking at. Number 4, the outcome of any trial is independent of the outcome of any other trial. And this is so for the scenario that we're looking at. If we toss the coin and we get a head, when we toss the coin again, because we got a head before, that has nothing to do with the next outcome, right? So the 4 conditions are present here for us to realize that this is a binomial situation. Now, if our random variable is binomially distributed, we normally denote it as x. We use this little symbol to indicate x is binomially distributed, BIN for short. And in brackets, we have the parameters of the binomial distribution. And the parameters for the binomial distribution, these are n and p. N is the finite number of trials, and p is the probability of success. So for the scenario before, n, the finite number of trials, would be equal to 40, and p, the probability of success, would be equal to 1/2. So when we're doing the question and we are denoting it, we will input 40 and 1/2 for the values of n and p respectively. Now there's a special formula for working out probability distribution. To find the probability, it's equal to n, the number of trials, n combination x, the variable, the value of interest, p, which is the probability of success, so the power of x, times q, which is the probability of failure, to the power of n minus x. Now the probability of failure is going to be 1 minus the probability of success, because p and q must be equal to 1. So let's look on this example. Let's consider 2 women. They're having babies. What is the probability that both of these women will have boys? Now, it doesn't indicate that it's a binomial distribution question, but we can recognize the 4 conditions that are present. The first one is that there is a finite number of trials. N is equal to 2. We're looking at 2 women. Okay, so n is equal to 2. The other condition is that there must be 2 possible outcomes, one of which is considered success and the other failure. So in this case, success is having a boy, failure will be having a girl. Okay, in this case, all right? The probability of success must be constant from trial to trials. That's the other condition. And the probability of having a boy is 1/2, right? And if you have, for you to have a next child, the probability of having a boy is still 1/2. Okay, so that's constant. And the other one is that the outcomes are independent. So the first woman having a boy will not have anything to do with the second woman having a boy. Okay? So our solutions now. In order to solve this problem, we need to define firstly what our random variable is. And x is the number of boys. That's what we are interested in, the number of boys. Okay? Now the number of boys is binomially distributed. N is 2 and p is 1/2. Now note that the possible values of x is equal to 0, 1, and 2. That means both women, none of them could have boys. That means both had girls, or one had a boy, or both of them had boys. So those are the possible values of x. Now let's find the probability that x is equal to 2, that is, both of these women had boys. Now remember, n is 2, x is 2, p is a half, and q is also a half. So we plug those values in the formula, 2 combination 2, and this is a function that you will find on your calculator. All right, so you press 2, then the combination button, then 2. Some calculators vary, so you should know how your calculator works. So that's n combination x, 2 combination 2, times a half to the power of 2, times a quarter to the power of, times a half rather, to the power of 0, gives you an answer of a quarter. All right, then we're going to look on another example. Okay. The proportion of allergy patients who show a positive reaction to a certain skin test is 0.66. Let us assume that an average of 5 patients a day are tested at the allergy clinic. Calculate the probability that among any 5 patients, 3 will give a positive reaction. So we are interested in the number of patients with a positive reaction to this test. So notice in the solutions, I've defined x as the number of patients with a positive reaction. All right. Now, x has binomial distribution. We are looking at 5 patients, so n is 5, and the probability of having a positive reaction is 0.66. That's our p. Okay. You would have looked at the question and realized that binomial is suitable because the 4 conditions are present. So now we're going to plug these values in our formula. We need to find a probability that x is equal to 3. The number of patients with a positive reaction is equal to 3. This is equal to 5 combination 3. Punch it in the calculator, whatever that works out to be. You're going to multiply that value by 0.66 to the third power, which is our x. Whatever that works out to be, we're going to multiply it by 0.34, which is the probability of failure, to the second power. Okay, we would have gotten 0.34 by saying 1 minus 0.66. So our answer would be 0.33. Another example, same scenario. The proportion of patients that show a positive reaction to the certain skin disease is 0.66. We have 5 patients. Calculate the probability that among any 5 patients, all will give a positive reaction. Okay, so in this case, x is equal to 5. The number of patients with a positive reaction is equal to 5. Okay, so 5 is our n, combination 5 is our x, times 0.66 to the 5th power, times 0.34 to the 0. And punch it in the calculator to get your answer. Another example, same scenario, 0.66 of the patients have a positive reaction. We're looking at 5 patients. Calculate the probability that among any 5 patients, 2 will give a negative reaction. Now notice this is a negative reaction, and the question told us 0.66 has a positive reaction. So in this case, our random variable of interest is the number of patients with a negative reaction. So n is 5, but p this time is 0.34. Because that's the probability of the patient having a negative reaction to the skin test. Okay, we are interested in the probability 2 of the 5. So therefore, x is equal to 2. So in our formula, 5 combination 2, p would be 0.34. We're going to raise that to the power of 2. Probability of failure will be 0.66. We're going to raise that to the power of 3. Punch it in the calculator. Your answer should be 0.0332. Another example, calculate the probability that among any 5 patients, at least one will give a positive reaction. All right, at least one means we're looking for 1 or more. So that means you have to find the probability that x is equal to 1. One patient had a positive reaction, x is equal to 2. We have to also find x is equal to 3, plus x is equal to 4, plus x is equal to 5. Okay, that's a tedious task. We can work this out easier because you may recall, or you should recall, that the sum of all the possible probabilities must add up to 1. So the possible values of x here, x can be 0, x can be 1, x can be 2, x can be 3, x can be 4, x can be 5. Now when you add all the probabilities associated with those values of x, it must be equal to 1. So instead of working out the probability that x is equal to 1, 2, 3, 4, and 5, we can work out the probability that x is equal to 0 and then take that answer from 1, because the sum of all of those probabilities must be equal to 1. Okay, so we can work this problem out by saying 1 minus the probability that x is equal to 0. So we'll have to find the probability that x is equal to 0, 5 combination 0, 0.66 to the 0, 0.34 to the 5th power. And then we're going to take that value from 1. All right, just a note that any value raised to the power of 0 is 1. All right. Now, the mean and the variance of a binomial distribution. So if x is binomially distributed with parameters n and p, then the mean, or the expected value or expectation, is equal to n times p. Whatever the value of n is, times p. And the variance is n times p times q. And if the variance is n times p times q, then that means the standard deviation is the square root of n times p times q.